we have our Unit 6 review over solving quadratic equations. Our first couple of problems do with solving by factoring. Problem number 1 is already factored for us, so we simply take each factor, the 5x plus 3, and set it equal to 0, and the 7x plus 1, and set it equal to 0. And now we solve each of these equations independently. The one on the left, I'm going to start by subtracting 3 from both sides. So I have 5x is equal to negative 3. I'm now going to divide both sides by 5. And I have x is equal to negative 3/5. The one on the right, I'm going to start by subtracting 1 from both sides. So I have 7x is equal to negative 1. I'm going to now divide both sides by 7. So I have x is equal to a negative 1/7. Problem number 2 needs to be factored. So I'm going to look and see what are my factors of negative 24. So I can have negative 1 times positive 24, or 1 times negative 24. I can have negative 2 times 24, or 2 times negative 24. I can have negative 3 times 8. Whoops. These are 12. 12 and negative 12. Negative 3 times 8, and then 3 times negative 8. And then I can have negative 4 times 6, and then 4 times negative 6. Now I need to find which pair of factors will add together to give me a negative 5. Here it is to give me a positive 5, which is negative 3 times 8. So this one's factored form is x minus 3 times x plus 8, and that's equal to 0. I now set each factor equal to 0 using our 0 factor property. I'm going to add 3 to both sides. X is equal to 3. Here I'm going to subtract 8 from both sides. X is equal to negative 8. For problem number 6, the first thing that I'm going to do is I'm going to multiply 6 times the negative 4. So I now have x squared minus 23x minus 24. Again, I'm going to list the factors for negative 24. Negative 1 times 24. 1 times negative 24, negative 2 times 12, 2 times negative 12, negative 3 times 8, 3 times negative 8, negative 4 times 6, and 4 times negative 6. This time I need them to add to a negative 23. Which would be 1 times negative 24. So I have x plus 1 and x minus 24. Since I multiplied by 6, I now have to divide by 6 to move it back. So I'm going to divide both of these by 6. 1 does not divide by 6 evenly, so this denominator moves in front of my x. So I have 6x plus 1. 6 does go into 24 evenly, so it's going to be x minus 4, and this is equal to 0. At this point, set each factor. 6x plus 1 equals 0. X minus 4 equals 0, and solve. The one on the left, I subtract 1 from both sides. 6x is equal to negative 1. I divide both sides by 6. X equals negative 1/6. Go on the right, I'm going to add 4 to both sides. X equals 4. For number 4, multiply my 2 over here. So I need to list the factors of negative 70. So I have negative 1 times 70, 1 times negative 70. Negative 2 times 35, 2 times negative 35. Negative 5 times 14, 5 times negative 14, negative 7 times 10, and 7 times negative 10. This time I'm looking for what is going to give me a 3, because this one becomes x squared plus 3x minus 70. So which of these will add together to give me a positive 3? My negative 7 and my positive 10. So I now have x minus 7, x plus 10. I move my 2 back by dividing both of these by 2. 2 does not go into 7 evenly, so that transfers to become 2x minus 7. 2 does go into 10 evenly, leaving a 5. And this is equal to 0. I set each factor. 2x minus 7 equals 0. X plus 5 equals 0. The one on the left, I add 7 to both sides. So I have 2x is equal to 7. I divide both by 2. And I find that x is equal to 7 halves. The one on the right, I subtract 5 from both sides. And I see that x is equal to negative 5. Each of these problems have the possibility of 2 answers, 1 answer, or no answer. Each of these here had 2 answers. Our next section here says solve each of the following by the quadratic formula. Remember, the quadratic formula is x is equal to the opposite of b plus or minus the square root of b squared minus 4ac, and that's all over 2a. Here we already have our ABC set up for us, so I'm going to go through and I'll plug in my a, which is 2, b is negative 3, and c is negative 20. So we go and substitute. X is equal to the opposite of, and again, it's always a good idea to put in empty parentheses when substituting into formulas to make sure that we're plugging the things in the correct spaces. Here I'm going to put negative 3 in each of these first spots. I'm going to put a 2 here and a negative 20, and then a 2 here. So a little bit of arithmetic. So I have positive 3 plus or minus the square root of 9 plus 160 over 4. So I now have x is equal to 3 plus or minus the square root of 169 over 4. So I'm going to have x is equal to 3 plus 13 over 4. I'm going to have x is equal to 3 minus 13 over 4. Again, each of these will have 2 answers. One on the left, x is equal to 3 plus 13 is 16, divided by 4 is 4. There's one solution. Here, we have 3 minus 13, so that's going to be a negative 10 over 4. But we have to take and reduce it, so this answer will be x equals negative 5 halves. Problem number 6. Same process. First, list your ABCs. A is going to be 6, B is negative 13, and C is 6. We go substitute them into the formula. Again, I like to go through and write the formula using a blank parentheses for every variable I'm going to be substituting for, to make sure that I'm plugging things in the correct spaces. I need B in the first space, that's a negative 13. B in the second space, negative 13. I need A, and I need C. On the bottom, I need A. So again, a little bit of arithmetic. I have 13 plus or minus the square root of 169 minus 144 over 12. So this becomes 13 plus or minus the square root of 25 over 12. So I now have x is equal to 13 plus 5 over 12, and x is equal to 13 minus 5 over 12. The one on the left is going to be x equals 18 over 12. You can simplify that by taking out a 6. So x equals 3 halves. The one on the right, x is equal to 8 over 12. We can reduce it by taking out a 4. So that's going to leave us with 2/3. And there are 2 answers for that one. Our next problem is still the same. First step, list my ABCs. 2, 5, negative 3. Next, prepare to substitute. Write the formula, putting empty parentheses everywhere there was a variable. Now go back and substitute. Proceed with our arithmetic. So negative 5 plus or minus square root of 25 plus 24 over 4. So this is going to be negative 5 plus or minus the square root of 49 over 4. 49 is a perfect square, so I'm going to have x equals negative 5 plus 7 over 4. X is equal to negative 5 minus 7 over 4. Here we have 2 over 4, which reduces to 1/2. The one on the right, this becomes x equals negative 12 over 4. 4 goes into 12 evenly, so this is negative 3. Our next section here deals with graphing on our quadratic functions. It says graph y equals x squared plus 7x plus 10. And then we got to go through and do the following. So my axis of symmetry. Remember, the axis of symmetry is a vertical line that says the opposite of b over 2a. The axis of symmetry is also the coordinate, x-coordinate, of our vertex. So in this case, remember my A, B, and C are located here. So my axis of symmetry is going to be x equals negative 7 over 2. So negative 7 halves, which that's 3 1/2. So if I go to the left, 1, 2, 3, and I put me a dashed line in between the 3 and the 4 on the negative side. At this point, I can go and use my calculator, because I know that this is my x-coordinate, negative 7 halves here. I can go into my calculator, turning it on. on. There we go. Let's clear this out. I have my y equals here. Make sure there's nothing in here for this. Here I have x squared plus 7x plus 10. Go and graph it. Here's what my graph should look like eventually. I want to look at my table. I want to go and set my table though. I want to start it at negative 5 because that's to the left here. I want to count by increments of 0.5 though, considering that this one is a negative 3.5 when converted to a decimal. So if I go and look at my table, notice I have decimals here. So at this point here, I can now find my vertex. It is 2.25. Well, since I already have this as a fraction here, let's change my negative 2.25 into a fraction. If we can't remember how to do that, I can simply do it here with the calculator. It'll automatically tell me that it's negative 9/4. My y-intercept, remember the y-intercept is always going to be 0, c. Well, c in this case is 10, so it's going to be 0, 10. My x-intercepts, to find my x-intercepts, I want to go back in here and say, tell my calculator to calculate my intersect, and there's my graph. I have curve 1, that's my parabola that I've punched in. Curve line 2 is going to be my x-axis, which is y equals 0. I'm going to come over here and guess my left one. It's about in this space here. Hit enter, and it tells me that it's located at negative 5, 0. I'm going to go back and do the same thing and find my second intersection. 5 for my intersection. Here's my curve. That's my parabola. Here's my second function, y equals 0. This time I'm going to guess over on this side. It's about in that space, so I hit enter. It tells me it's at negative 2, 0. Now here's asking me to complete the table. Well, I already have a table completed, so I have to go and just write my values. I need negative 1. So I move down on my scale here till I find negative 1. And the answer to that would be 4. I need negative 6. If I go back this direction here and find negative 6, and that will tell me this one is 4. I now have all my information that's needed to graph my equation, my function. So I'm going to go through. My vertex is going to be on my axis of symmetry, and it's going to be down 1, 2 1/4. So it's about right here. Next, I'm going to plug in my intercepts. My x-intercepts are at 0, negative 5. So this is 3, 4, 5 right here. And it's negative 2, 0, negative 2, 0. I have the point negative 1, 1, 2, 3, 4. And I have the point negative 6, 4 as well. And I also have 0, 2, 4, 5, 6, 7, 8, 9, 10, which means that there's one over here that's the same distance. Right here. Since these are a mirror image of each other. And there's a sketch of my parabola, which does look like what was on the calculator. Looking at our last one we have here, it's asking us, they gave us a graph and said, go fill in all this information about my graph. The first thing it asks for is the vertex. The vertex is this point right here. This point is located at 1, 2, 3, then up 1, 2, 3, 4. So my axis of symmetry is always the same as the x value of my vertex, so it's x equals 3. This one is going down. Since it's going down, it has a maximum value, and it's going to be y equals the same as my vertex, 4. My domain is going to be all real numbers, because x can be anything that we want it to be. Now the range. The range does have some restrictions. The range is going to be less than or equal to whatever our maximum value is. In this case, it is going to be 4. Now my x-intercept. The x-intercept is going to be at 1, 2, 3, 4. It's this point right here. So that's going to be 0, negative 4. The x-intercepts. The x-intercepts are going to be right here and right here. This point here and this point right here. The first one's at 1, 0, and the second one is located at, let's see, that 1, 2, 3, 4, 5, 5, 0. Now my roots. The roots are the same as the x-intercepts. That's going to be 1, and this is going to be 5. My zeros. The zeros are the same thing as the roots, which are the same thing as the x-intercept, so that's going to be a 1 and a 5. And now it asks for my solutions, and well, my solutions are the same as the zeros, which are the same as the roots, which are the same as the x-intercepts. So it's still going to be 1, 1, and 5. This is all the tools that you're going to need for our exam. Good luck.